Hi, everyone. Welcome back. Our next speaker is Tim Phipps, Director of Cloud Alliances, EMEA of thales. Tim's session will explore the question, can you trust the cloud with your sensitive data? Tim is the EMEA Director of Alliances at thales CPL and is responsible for helping organizations take control of their digital sovereignty and accelerate their journey to cloud. Tim has held senior sales and business development roles in EMEA, APAC, and the US, working on digital transformation programs across highly regulated industries such as finance, telco, and the public sector. Please help me welcome Tim Phipps to the stage.
Hi, my name is Tim, Director of Cloud Alliances at thales. It's a pleasure to speak with you today. And the topic of my presentation is the question I'm often asked by end customers, which is, can we really trust our sensitive data in the cloud? So in today's agenda, we're going to look at some of the market drivers behind why organizations are wanting to move sensitive workloads in the cloud. And we'll do a little focus on GDPR and Schrems 2. What is the impact of Schrems 2? What is happening now with the EU and the US now that they are trying to overcome some of the concerns that were raised by Max Schrems around data privacy? We'll spend most of today actually looking at different options that organizations may have if they want to remediate risk and move sensitive workloads into the cloud. And finally, we'll look at a few customer success stories where thales has helped organizations speed their journey to the cloud. So according to Gartner, by the end of this year, 2022, cloud spend will have grown to about 544 billion, which is 20% year-on-year growth. There are a variety of reasons, of course, why organizations want to move workloads to the cloud. They may be performing cost optimization, for example, closing down data centers. They may have a specific corporate initiative to become more cloud friendly. They, of course, want to take advantage of new services that are available in the cloud, such as AI, ML, and big data. They may have already signed a large commit with their cloud provider, and they now need to retire that commit. And of course, most organizations start off by moving easy workloads, non-sensitive workloads to the cloud, but many of the sensitive workloads still remain on-prem. Now, one question that you might be asking is, why can't I just rely on the native security that my cloud provider offers me? All cloud providers encrypt their data by default. So what do you need to do over and above that in order to satisfy various compliance laws? Well, we must remind ourselves about the concept of separation of duty, because whilst the cloud providers themselves are responsible for the security of the cloud infrastructure, the data processor, that is the organization that is holding and processing sensitive data, such as customer records, financial data, medical records, corporate IP, they are responsible for ensuring the privacy and security of that data once it is inside the cloud itself. And this was really echoed by the thales 2022 Data Threat Report, where we interviewed about 2,800 IT security professionals. We asked them for their opinions on a variety of data security topics. And one of the questions we asked them is, what keeps you up at night when it comes to migrating sensitive data to the cloud, and what's actually preventing you from doing that? Three of the major concerns that they raised were the issue of nation state. So this is the subpoena threat, the fact that a foreign government might try to forcibly access your data or perhaps do it behind the scenes. The threat from malicious insiders, so bad actors internally trying to access that data once it's in the cloud. And another common theme that emerged was human error. Now, according to Gartner, 95% of data breaches can ultimately be attributed to human error. That might be an issue because your teams are not following processes. For example, they're not rotating their encryption keys in the right way or at the right frequency. They may have on your cloud provider a misconfiguration issue, which has exposed a data breach. But for whatever reason there is, I think generally speaking, the idea of simplifying IT and automating IT to remove the human element is always going to reduce your threat surface. So we mentioned GDPR. Now, GDPR applies to any organization which is processing the personal information of an EU citizen or an EU resident, and it applies to any organization, not just those that are physically situated in the EU. So if you're a large corporate organization based, for example, in the US, and you're offering services to EU citizens or EU residents, then GDPR does apply to you. And of course, what a lot of CISOs are concerned about, that if you are breached and you are found by the European courts not to have been following the correct practices according to GDPR, then the fines are quite large. They could be as high as 4% of global revenue or 20 million euros, whichever is higher. So this is one of the reasons, not the only reason, why CISOs are concerned about GDPR. And of course, the problem was complicated because of the Schrems II ruling that was made, which invalidated the EU-US Privacy Shield. So a lot of organizations are a bit confused about how can they confidently move sensitive data into the cloud in such a way that they're following best practice and not subject to being found to be in breach of GDPR. Let's talk a little bit about compliance, because when I talk to organizations, they're asking me, what should I do to be compliant with GDPR? And of course, the answer is, it depends. There is no single answer. It's a bit like this scenario here, where you've got a monster truck. It's got a spare wheel on the back. And of course, the purpose of having a spare wheel is to promote road safety in the case that you have an accident, you have a blowout. But here, you're really just ticking the box. You're providing a tick in the compliance box, but not anything which is effective. And so I think one of the key messages is that when you're thinking about being compliant, compliance should be seen as a business enabler. It's not a tick in the box exercise. It's not a business blocker. And one of the best ways of ensuring that you are compliant is to deal with the issue early on in your cloud migration, not towards the end of the project when your DPO or your compliance officer may raise a yellow or red flag saying that you can't do that. So what's happening with Schrems II now that the EU-US Privacy Shield from the last time round was invalidated? Well, you may be aware that in March 2022, the 25th of March, there was an announcement made by the EU and the US declaring a new transatlantic data privacy framework. And they targeted a new set of rules which will be published within 6 months. Well, that was 25th of September, and no such announcement has been made. And so if you go to the European Centre for Digital Rights, which is sponsored by Max Schrems, the Austrian lawyer who originally raised these objections with the European courts, and you look at his group, they're often called NOYB, or None of Your Business, they place quite a concerning, I think, assessment of what's gone on so far, because the language coming out of the US seems to be, according to NOYB, a rehash of what's already gone before. There doesn't seem to be any confidence that this new Privacy Shield 2 agreement is really going to remedy the issues that were raised by the European courts. And the problem is, the longer this goes on, it creates more uncertainty for organizations. How can they progress their digital transformations if they don't know what to do? So at Thales, we say there's no point in waiting around, because you're always going to face change. Okay? There's going to be geopolitical change, there's going to be economic change, there's going to be social changes. The whole landscape right now, of course, is fraught with danger. But organizations need to carry on with their business transformations. And the way we propose that organizations can do that is to take control of their digital sovereignty. So this is a World Economic Forum definition. Digital sovereignty refers to the ability of an organization to take control over its digital destiny. That's the data, the software, and the hardware that they rely on in order to perform their operations. And there are actually three pillars of digital sovereignty. So the one that I guess most people are familiar with is data sovereignty. So when we hear about GDPR, we hear about the subpoena threat. That's the threat that a foreign state will request or get access to your sensitive data. But there are also two other elements of digital sovereignty which are super important. One is operational sovereignty, which is the idea of protecting against internal threats, so bad actors. It could be a CSP engineer, it could be one of your own members of staff who's been hired recently. It turns out to be somebody with nefarious motivations, perhaps steal money. Could also be ransomware, so some sort of process which steals the credentials of a privileged user and then uses it to get access to your sensitive data, or perhaps encrypt it so that you can't perform your functions until you pay that ransom. And increasingly importantly is software sovereignty. So this is the idea that organizations increasingly are being required to show that they haven't put all their eggs in one basket. So they're not totally locked into one single cloud provider. Now, I must stress there's a difference between intentionally putting all of your workloads with one cloud provider, which may commercially be sensible if you can sign a commercial agreement that makes sense, and having the option to then move your workloads out to a different cloud. This is what software sovereignty is all about. It's showing that you can perform a stressed exit if you need to. For example, if there is an outage with your main provider. And most organizations these days are increasingly going multi-cloud in a way to address this. And you see regulations, for example, in Europe, such as DORA, the Digital Operational Resiliency Act, and in the UK, the Prudential Regulation Authority, actually mandating its members in the financial services sector to show that they can freely move workloads from one cloud to another, or even repatriate them back on-prem. So how can you control your digital sovereignty? Well, Thales's approach is through something called our Cipher Trust platform, and we have a kind of four-step model for this called discover, protect, control, and monitor. You need to discover where your sensitive data is. You need to protect it accordingly. You need to control access to the encryption keys to only those users or processes who have the right to access those keys. And then you need to monitor the whole process again, because data is constantly changing, regulations are changing, and it's not just a set and forget. So let's start with discover. So in a survey performed by Thales, we asked a number of CISOs, did your organizations know where all of its sensitive data was? And 54% of the respondents said yes, they knew where all their sensitive data was, but of course 46% said yeah, they were concerned because they didn't have a full grasp of where all the sensitive data was located. And this is not surprising, because according to Gartner, I think there's 2.5 quintillion bytes of data being generated on a daily basis, and most of that data is actually unstructured data. So it's comparatively easy to actually encrypt and protect data if it's stored within a database in known locations. But a lot of this data now that's being generated is video, it's email, it's audio, it's in unstructured formats, so that if at any point a process, a person could be creating sensitive data, storing it in a location when previously it was not realized that sensitive data would be stored in that way. So in terms of managing risk, I think this is the really important point here, that rather than just focus on compliance, we need to focus initially on governance and risk management. If you don't do those two things, it's very difficult to demonstrate compliance. Why do I say that? Managing risk isn't just a technical method. It's not just about applying the latest and greatest cryptography and key management. You've got to think about the business outcomes you're trying to achieve, the needs of your customer, the varying cybersecurity threats, operational performance. For example, are you applying techniques which will significantly degrade the service that you're offering your customers, your business partners? As we've heard before, regulatory compliance is constantly changing. There's about 70% of countries around the world that have now implemented GDPR or something equivalent. And there is also this newly generated data that I mentioned, the 2.5 quintillion bytes of data that you've got to manage every day. So with Thales, we've actually got a solution called data discovery and classification. And there you can actually identify particular regulations such as GDPR or PCI DSS if you're an FS&I. You can look at HIPAA if you're, for example, a hospital working with medical records. And with DDC, you can search through all of your databases, your data warehouses, your data lakes. And against target regulations, DDC can actually search through your data stores and actually extract data that complies or falls under the auspices of those regulations. It can then look at the nature of the data. Is it names, addresses, phone numbers, credit card information? And it can then associate a risk score from, say, 1 to 10, where 10 is the highest risk and 1 is the lowest risk. And it can then identify to you as an organization what steps you could take to remediate that risk. Now, you can actually choose to remediate risks in a manual way, or with DDC, we've actually got an option where the system can actually do that automatically for you using a variety of encryption methodologies. So let's look at Protect. So Protect is basically a series of encryption techniques. First of all, of course, we must remind ourselves that not all workloads need to be encrypted over and above what the cloud providers offer you. If it's non-sensitive data, then by all means, just use native encryption and native key management. But at some point, organizations moving sensitive data to the cloud will want to move and address we'll want to use additional techniques to encrypt that data. And first of all, we see a lot of organizations moving VMs as part of an infrastructure as a service migration. And there, the advantage is the cloud provider cannot access the decrypted VMs, but the potential disadvantage is that you're not able to use all of the native cloud services. What we found is that a lot of organizations have gone one step further. They started off by quickly moving VMs into the cloud, and they're now starting to rewrite legacy applications, either by replatforming them, but then rebuilding or re-architecting those applications using cloud-native services. And containerization of cloud-native apps seems to be a common theme amongst many organizations who initially moved to the cloud a few years ago. What you can do there is use a variety of techniques that cloud providers are offering in conjunction with partners like Thales to provide better sovereignty controls over native applications that are run in a pass mode. Data tokenization and masking are a couple of examples where, for example, you might go in and specifically remove sensitive data, such as a credit card information, before you move it to the cloud, or you might mask certain elements of sensitive data so that only certain users with the right to see that data can access the unmasked data. You might also want to encrypt specific files. You might want to protect storage, which is attached to containers. And this is also a new capability that Thales is now supporting. And we're seeing a lot of organizations now rewriting applications, wanting to protect storage associated with those containers because it promotes portability. Remember the concept I mentioned earlier about resiliency, the freedom to move workloads from location to location. If you make sure your storage is in a container and you're encrypting it, not only are you helping to support sovereignty, but you're also helping to support data portability and data resilience. CSPs are now going one step further. They're also investing heavily in confidential computing. So this is the idea of actually creating like a secure enclave, typically with a hardware device, where the VM is running within a fixed and a secure environment. So the cloud provider cannot get access to even the data as it's being used. It's only the entity that has access to the encryption keys that can do that. And Thales is also providing external key management capabilities that work with confidential computing. So let's look at the let's look at the control phase of discover, protect, and control. So again, if you're only using cloud-native encryption and key management, it's a little bit like leaving your keys under the mat when you leave your house. Again, if you're using it for non-sensitive data, there should be no issues with that. But if you're using it for sensitive data, it's not really a best practice. And this is reinforced by the European Data Protection Board, who, in response to Schrems 2, provided some guidance about best practices that organizations can take if they want to ensure that they are demonstrating compliance with GDPR. And some of the advice that they gave is to make sure that your keys are reliably generated and stored. Typically at Thales, we would recommend putting them inside a hardware security module, a FIPS 142 level 3 hardware security module, the type that is used by governments and banks worldwide to store their master keys and their encryption keys. They also recommend making sure that you retain full control of your encryption keys. So this is typically making sure your keys are always held outside of the CSP. And a number of CSPs, such as Google, have provided technologies that allow you to do that quite easily. And also, in some instances, you might actually want to encrypt workloads before you move them into the cloud. So encryption, such as a VM encryption, such as encrypting at the file level, at the database level, at the application level, would be examples of that. So thinking about key management, there's different approaches to that. So again, if you're using native key management and native encryption, then just use the capabilities available from your CSP. All of the major cloud providers support what we call bring your own key, which is when you're generating your keys externally and you're bringing them into the cloud, and then the cloud service will then access those keys to decrypt the data. Hold your own key is an example of making sure that your keys are never accessed by the CSP, and increasingly organizations are looking at this type of approach to ensure that they have additional sovereign controls which they can use to demonstrate compliance to the regulator. And CSPs are increasingly investing in solutions like this. And again, bring your own encryption, which was another level of sovereignty above. But again, the trade-off is going to be that you're not necessarily going to be able to use all of the native cloud functions. Another way of addressing sovereignty is the way in which the cloud is actually set up and where it's actually located. So obviously, the most flexible solution is if you're using a public cloud or public multi-cloud, because you're getting the highest levels of functionality, the highest levels of resilience, which you don't always have full control over where your data is stored. Then there are variants of that where you can have a sovereign cloud. So some of the CSPs now are working with trusted partners, SIs, telco providers, to set up cloud in particular countries, either initially to perform the key management or actually to run the data center itself with copies of the software running within that data center. So there's effectively an air gap between the CSP and the sovereign cloud provider. And Thales, for example, has a solution called SONS, which we're running in France, where initially we're controlling keys, and ultimately we'll have a fully sovereign offer, which is run by Thales employees for organizations who have particularly stringent requirements for sovereign data to make sure that it's not in any way under the control of the hyperscaler. You're seeing particular variants, for example, in defense. Organizations in defense obviously super careful about where their data is accessed. So it's quite common for them to actually deploy a private cloud running on-prem. So you get the benefits of cloud, but it's under their control. And also you're seeing hybrid solutions such as Cloud Edge, where you're having hardened computing devices which are stored much closer to where data is used or data is captured. So again, you're getting the benefits of the cloud, but you're also providing additional controls over sovereignty. You also see sovereign controls vary according to the nature of the migration to cloud. And the reason why I mention this is because it's really important to know that not every combination of sovereign control is available in every cloud scenario. Over time, we're seeing those options fill out, but it's really important to work with an organization who can give you best advice on what combinations are right for your particular cloud migration scenario. So, for example, if you're doing some lift and shift, Thales has a partnership with VM, because that's one of the most common ways of doing virtualization, to move legacy VMs into the cloud of your choice, whilst making sure that you retain full sovereignty of your data that's inside. If you're doing re-platform, again, you might be using, for example, Kubernetes, and you want to rebuild or re-architect your legacy apps. There are certain functions available for supporting sovereignty that are available today that will grow over time. There are other functions that are not available. And again, external key management, whether it's hold your own key or bring your own key, that's available for certain services in certain clouds. For example, going to the next level, if you're looking at SaaS, Microsoft have a solution called double key encryption, which allows you to protect access to your Office documents, Microsoft 365. Google has an equivalent solution called Google Workspace CSE. Again, you can protect your documents and make sure that the CSP cannot access your sensitive data. It's also important to think about the data state. So a lot of what I've said so far over the last few years has really focused on data at rest. So that's data that's stored physically in storage within the CSP. What customers are now asking about was, well, it's okay if my data is protected if it's physically stored somewhere, but what about when it moves to a different location across a network boundary, for example? What happens if it's being used by a processor? Isn't there a danger that somebody could access my sensitive data there? And so you're seeing more and more solutions for encrypting data in transit or in motion, as well as data in use. Confidential computing, as I mentioned before, is one such example of that. We were speaking with an organization which is an energy supplier, and they are still a bit nervous about putting super sensitive workloads in the cloud. They want additional assurances that there is no danger, for example, that somebody could inject some malware into a processor and start either accessing sensitive data, or even worse, causing that system to shut down. Perhaps it's terrorism or espionage, for example. So confidential computing is a typical type of technology that, in theory, could obviate that risk. And let me give you an example then of how Thales typically works with organizations to recommend solutions. So in this particular example, you've got different types of sensitive data, but we're working in this case with a bank, and they say that they've got financial records which they need to access on the cloud because they're building a new customer service portal. So in this case, the information is stored at rest, and they are trying to re-architect their application, so they kind of completely rebuild it so that it's fully cloud native. They want to use some AI, they want to use some ML. So this data is in a public cloud, and in this specific scenario within the help desk, they're worried about the scenario where a customer's identity needs to be verified. So we would recommend something like dynamic data masking. For example, if you need to share information from a memorable word as part of your password, then you don't want that password to be fully exposed to the banking operative who's servicing the customer. You might have credit card information which you need to store, so typically you'd want to tokenize it because you want to swap out that sensitive information for some random numbers so that nobody can access those credit card numbers and start spending on behalf of the customer. And of course, you want to use external key management. So ideally, anytime you're encrypting sensitive data, make sure you control access to those keys, and ideally store the keys outside of the realms of the CSP. So let's have a look at some customer success stories. So this first organization that we worked with was a global food manufacturer, and they're already at the multi-cloud stage. So they're in AWS, Azure, GCP, and Oracle. What they had found is they started off using the native key management stores and native key processes that each of those public cloud providers had offered. And they ended up having to have dedicated teams to do key rotation, key management, and basically it became inefficient. And it kind of reminds me of the comment that Gartner made about 95% of breaches are attributed to human error, because in this case, after an audit, this organization found they were in breach because each group that was managing the dedicated cloud were managing the life cycle of the keys and the storage of the keys in completely different ways. There was no harmonization. So this particular organization asked Thales to provide them with a centralized platform, a single pane of glass, which they could harmonize the key management across a single platform and get a 360 visibility of where all their keys were. They also found that it helped them demonstrate compliance with resilience, because by operating a single external platform for key management, it helped them demonstrate that they were not fully locked into a particular cloud provider. And as well as increasing efficiency and allowing them to streamline the team that was needed to manage this key management, the time to value was less than 9 months. In this second example, this is a large international bank with over 5,000 branches. They had a cost savings drive, so they decided to close down some data centers. They wanted to move 60 Microsoft servers that were on-prem into Azure. The compliance team, however, blocked it because a lot of this data had been captured actually during COVID, when this particular bank had started to deal more and more with its customers online, and it started to onboard new customers using video. So, as I said previously, you potentially, with unstructured data such as video and audio, have a lot of sensitive data being stored. It's not always easy to know at what point in the video that information is revealed. So the idea here was to encrypt these workloads in VMs before they were moved into Azure. So this is an example of bring your own encryption. And as a result of that, the DPO and the regulator said, that's fine, you can now move these workloads into Azure. And the time to value was about 6 months. And this particular bank has told us that they expect 100% ROI in less than 3 years. In this third and final example, there's a global pharmaceutical supplier. So this particular organization was with Google Cloud. They're actually hybrid multi-cloud, scenario that they were preparing for, but initially their first cloud that they went to was Google Cloud. Now, again, they had a lot of VMs, so they wanted to move them straight away. So the lift and shift of VMs was the first port of call, but they immediately started to think about how they could redesign their ordering system. And because they're working with suppliers, they want to use AI and ML to get a better understanding of the purchasing behaviors of their customers and the supply behaviors of their business partners. But the regulator raised a yellow flag saying, not only does this potentially come under GDPR because you're dealing with supplier information and customer information, because this organization also had offices in the US, HIPAA was also applicable. So you're dealing with HIPAA and GDPR. So this particular organization has decided to rewrite its applications using Google's EKM capabilities, as well as support for VM encryption using external key management. And as a result, they've been able to speed up their journey to cloud, 30% more workloads are now running in the cloud compared with the situation before when they were running their on-prem system. So in summary, if you want to trust the cloud more, first of all, remember it's not a one-size-fits-all. You really need to take a risk-based approach to controlling your digital sovereignty. And remember, the approach that we recommend is discover, protect, and control. So discover where your sensitive data is, try to understand the risks, and decide how you want to remediate those risks using appropriate levels of encryption. In terms of control, make sure that you know where those keys were generated, that they have a strong entropy, for example, that they can be trusted, not easily duplicated. stored in a secure location outside of the control of your CSP. That's the best way to demonstrate you are in full control of your sovereignty, and to make sure not only do you have data sovereignty and software sovereignty, but also operational sovereignty as well. So if you'd like to learn a little bit more about how Thales is helping organizations control their sovereignty, we have a digital sovereignty ebook, which is available through the link that's displayed here. You may read the 2022 data threat reports, got all sorts of useful information about what customers such as yourself are thinking about, and what challenges they face, and how they're trying to address them. You can learn a little bit more about Thales's CPO solutions for protecting sovereignty. Again, our contact details here. If you have more questions, if you have a project, for example, where you'd like to know a little bit more, perhaps we can help you. And if you'd like to know a little bit more about the CipherTrust platform, then you can scan the QR code on the screen. It'll take you straight through to a web page that will give you an interactive tour.
Hi, Tim.
Hey, Kayla. Very nice to meet you.
Nice to meet you too. Thanks for joining us live, and thank you for your presentation.
Welcome.
I've got some questions here for you. We've got about 10 minutes, and I have quite a few questions, and if you have more, please put them in the Q&A, and if we don't get to them, we'll send them to Tim. But to start with, which specific data transmission do you encrypt?
Okay, so when you talk about data transmission, are we talking about data in transit?
Yes.
I don't know if we could ask the person who asked the question. I mean,
sorry, I'm not sure, but
yeah,
let's assume so.
So a lot of our encryption techniques are encrypting data at rest. Okay, if we're talking about data transmission, we do have a solution called high-speed encryption, which is basically an improvement on the kind of standard TLS offer that you get over the internet. And so it's working at super high rates. And we get a lot of interest, for example, for customers, for example, who have IoT applications who want to use high-speed encryption at the edge, who need that data to be secure, need to control their sovereignty, but can't get the performance they would need from simple kind of TLS type connections. So high-speed encryption would be the one that we would use if we're talking about the transmission of data. Majority of our encryption techniques, as I said, are data at rest, but we also are involved with the major CSPs to support them on their confidential computing, which is where we are helping them to protect the data in a secure enclave, which is data in use.
Okay, thank you, Tim. Our next question here is, what do you do to prevent data from being hacked and stolen? It's a pretty general question for a very specific process, but
yeah, I mean, it sounds like a simple question. Of course, the answer is it's multifaceted. Look, first of all, I would never believe any vendor who tells you that there is a solution that is completely foolproof. Again, we're all about mitigating risk. It's about using the right tool for the right job. We obviously invest heavily in standards-based implementations. We also invest heavily in next-gen technologies. You may have heard in the news that Thales was selected in a consortium that's creating some of their net algorithms so that they are kind of quantum proof and quantum resistant. But the simplest mechanism is, there is kind of defense in depth. It is to produce an agile system. Again, we have a lot of technologies, for example, at the encryption level, where we go above the disk level, so we can encrypt files, we can encrypt columns in databases, we can help encrypt applications, we can tokenize data. Doesn't matter what encryption techniques you're using, of course, as hopefully my presentation has emphasized. It's all about who's controlling those keys. It's about proper governance processes of rotating the keys, controlling access to the keys, making sure that access is given based on role and the need to know, making sure that you retire or expire the keys, store them in a secure location, ideally a FIPS 142 level 3 kind of HSM. And also, I think, thinking about the human element as well, reciting what Gartner said about 95% of breaches come from human error. So what we see with customers is they're often using kind of disparate systems, and each system has its own peculiar way of operating. And we've come across quite a few examples where, for example, people who run those systems kind of then leave the company, and they take away that kind of very specific knowledge, and then they leave a gap, and that's when failures of audits happen, because there's a particular person they were relying on to perform a particular key rotation, and that person isn't doing it anymore. Nobody realized, because they were kind of operating in a silo. So our real mantra is the more you can consolidate your view around sovereignty, around encryption and keys, base it on risk, constantly reviewing and monitoring what your exposure is, the more you can standardize and eliminate those kind of like point solutions. You give that customer a kind of a 360 view that makes it much easier for them to understand what the threat surface looks like, what the risks are, and how they should mitigate them accordingly.
Okay, thanks, Tim. That makes sense. Great answer for a simple, complicated question. Thank you. Our third question here is on-site infrastructure safer than the cloud?
Sorry, could you repeat the question, please?
Is on-site infrastructure safer than the cloud?
Oh, well, that's funny, really, because I just kind of came off a call with Microsoft, actually, where we were talking about some projects in Europe for some governments. And, you know, I think we probably all realize now that there's a difference, isn't there, between being comforted because it's something you've already done, and that you've all, you know, and therefore you just assume that's the way we've already done it, therefore it's secure and it's safe, and then being afraid of the unknown. I remember trying to convince people early on in my career, because I originally came from the biometrics industry, why facial recognition, fingerprint recognition could provide added layers of security to people in the banking industry. And they were absolutely adamant that there were potential ways where they could be hacked, and therefore it wasn't secure. And they felt it was much more secure if you used a PIN number on its own, which we all know is ludicrous now, but that's how people thought, because that's what they knew. And I kind of would say the same really with on-prem and in the cloud. It does depend on the workloads that you're looking to protect, and again, what regulations you have to comply with. But I think increasingly, the security regimes that are offered in the cloud, if you combine it with the right sovereignty controls, are starting to, in some cases, even surpass what's available on-prem. For example, Microsoft don't offer, and I don't think Google either, there's no support for confidential computing on-prem. Okay, I mean, I know customers, and of course I won't name them, who don't even encrypt their data when it's on-prem, because they are comforted by the perimeters of the physical wall, which again we know is ludicrous, but that's the way they've always done it. And now they're moving into the cloud. There's a whole raft of regulatory compliance they've got to pass, because they're moving from something which we know inherently is insecure to something that perceptually is less secure because it's in the cloud. And yet in the cloud they get that benefit of protecting data at rest, in motion and use, control of the keys. They've got much better SIM applications that are controlling and monitoring, how that data is being used and accessed. And you can control it with IAM solutions as well. So I think I'm not going to say the cloud is the be all and end all and everything is perfect, but I think if you use the right tool for the right job, again, it's based on risk, you can be very secure in most instances for your workloads. And of course, there are variances of the cloud as well. I think I mentioned earlier in my presentation, we often think of the cloud as public cloud, but there are sovereign clouds, there are disconnected clouds, there are cloud edges. And again, it's just using the cloud in the way that makes most sense for your business. But what you do get in the cloud, of course, which you don't really get on-prem, is the benefit of all those wonderful innovative services like AI and ML that gives you the ability to work through your data and deliver better services to your customers, your business partners.
Makes sense. Do you think generationally, perhaps that will change? That the next generation will not sort of see on-prem as a preferred method?
Yeah, I mean, I have to hold my hand up and say I'm kind of starting to become an old timer myself, and you see the next CTO or CCO come through the door who's a lot younger than you, and you think, oh, and that's all they've ever known is working with apps, and they're totally thinking about the digital native, cloud native. We work with a lot of organizations, for example, challenger banks who've only ever existed in the cloud. They've never had bricks and mortar data centers. So that's kind of what they accept and what they know. So I think you're spot on there, is that as people increasingly just come to accept that working in the cloud is the norm, and this is, of course, going to be happening as more and more organizations are closing down data centers and looking to consume SaaS services. It won't be a question of, do I move to the cloud, but either how quickly can I move to the cloud, and what do I do? You know, how can I take best advantage of this fantastic infrastructure and technology? Yeah, and it won't be a case of looking back at your bricks and mortars data centers in most cases.
Yeah, I think this is a case of don't be afraid of the future. There's a lot that can change in 20 years. Thanks, Tim. I appreciate, we're just running out of time here. We're going to move on to our next presentation, but thank you so much. We have a few questions here that we didn't get to, but we'll share them with you. And then, you know, recommend that anyone watching today just gets in touch with you in the comments and the chats. And thank you so much again for being live with us today.
You're welcome. Thank you.
Thanks, Tim.